Good morning, students. Today we are going to discuss few application of dimensions. Already we have discussed two applications. Now today we are going to discuss third and fourth application. Now let me start with the third number of application, obtaining relation among various physical quantities. So we can use dimension to define the relation among physical quantities. Now what we have written, let me read out. The relation among various physical quantities can be obtained by using the principle of homogeneity of dimensions. So principle of homogeneity already we have discussed. Please check the previous classes. Now how can we use principle of homogeneity in defining relation among physical quantities? Let me explain by considering one example. Now what we have written here, suppose that the oscillation of a simple pendulum depends on, that is nothing but the time period of oscillation, depends on number 1 mass of bob, number 2 length of string L, number 3 acceleration due to gravity. So these are the factors on which time period of a simple pendulum depends, and our job is to define the expression of time period in terms of these physical quantities. So what we have written, derive the expression for time period using the method of dimensions. So we are going to use dimension in defining relation of time period with these physical quantities. Now it is not explained that how the time period depends on mass, length and acceleration due to gravity. Is not it. Here it only specify that time period depends on these physical quantities. So as we don't know how it depends, let me consider time period capital T depends on small m, that is your mass, and exponent is your a. So our job is to define the constant a. If we can define the constant a, then we can say how time period depends on mass. Similarly, length of the string, that is small l, it does not say that how time period depends on length, but it says only time period depends on length, but how it depends it does not specify. So that's why let me consider t proportional to L to the power b. So our job is to define b. If b is your 1, then it directly proportional to length. If b is your minus 1, then it inversely proportional to length. And a, b, these are any numerical values, maybe 1, 2, 3, 4 like that. So our job is to define these values a, b and also c. So time period depends on acceleration due to gravity, but it does not says how it depends. So here also you have consider t proportional to g to the power c, and our job is to define these constant a, b and c, where these are constant numerical values. So what we do now, we'll combine time period with these physical quantities. So t proportional to m to the power a, L to the power b, g to the power c. And if you want to remove this proportional sign with the equal sign, then what we have to do, we have to bring one constant. So here k is the dimensionless constant. Okay, constant and dimensionless constant, there is a difference. Some constant have dimension, for example gravitational constant, but here we are considering this k is your dimensionless constant. It does not have dimension, and we have specified this expression with the equation number 4. Now let me continue. So our job is to define writing dimensions of each term on both sides of equation 4. So this is your equation 4, and we have to write dimension of each term. So t, here is given time period, so we can write time period t1 with the third bracket defined. We are defining the dimension for time period. So mass, that is your is given m to the power a. So mass is your capital M, so it is 1, so exponent 1, but within the third bracket we are defining dimensions with the small a. Similarly length 1, as it says length L, so that is your b. Now acceleration due to gravity, the acceleration dimension is your L1 t minus 2 with the c. So this is nothing but the as it is in terms of product, so we have to add the exponent. So m here have only one term, so m to the power a, l b as well as c, so b plus c exponents get added in case of product, and t to the power minus 2c. Now according to the principle of homogeneity, what homogeneity says that the dimensions are identical, no? So in left hand side we don't have dimension for mass and length, so you can consider it is mass dimension is 0, length dimension is 0, but t dimension is 1. So a goes to 0, b plus c goes to 0, and 1 equal to minus 2c, so c equal to minus half, and b plus c 0 means b equal to minus c, so equal to plus half, so c equal to minus half and b equal to plus half. So this constant value we have to substitute in equation number 4. So t equal to k, a value coming out 0, so m to the power 0 is nothing but 1, so we are not supposed to write m to the power a, and length that is your b value is your half, so l to the power half, and g value is c, c equal to minus half, g to the power c, so g to the power minus half. So you can make this one in terms of square root over L by G. So T equal to K root over L by G. Now experimentally it is found that K equal to 2 pi. So the final expression you will get T equal to 2 pi root over L by G. So this expression is in your syllabus in oscillations. So you will get this expression later on in your theory class, that is in oscillation chapter. So this is one application of dimensional analysis. You can find the relation among physical quantities using dimension. Now next application is your finding dimension of constant in physical relation. Suppose a relation is provided to you, you can find the dimensions of constant. So what you have written here, to find the dimensions of constant in given physical relation, the concept used as the like quantities can be added or subtracted from each other. So definitely you can add velocity, but you are not supposed to add velocity with acceleration. You can add mass with mass, but you are not supposed to add mass with time. So if I give you some expression, for example, under note number 1, v equal to a by t plus bt square. So v is nothing but sum of two terms. So v define velocity, so a by t also define velocity, bt square also define velocity. So velocity dimension is your lt minus 1. So a by t equal to lt minus 1. So you can define dimension for a. bt square, t is your time. So again it is the dimension of bt square equal to lt minus 1. So you can simplify and find out b. So you can define constant for a and b because we are expressing velocity in terms of two terms. As v is the velocity, so each term must have velocity, because when velocity gets added you will get velocity. So a by t also dimension of velocity, bt square also dimension of velocity. Similarly you can define E equal to b minus x square by at. So as we are subtracting b minus x square, so and x is distance, so dimension for x square is same as dimension for b. Now as E is the energy, so b minus x square by at also define energy. So using this concept we can define a and b. So constant can be defined by considering that like quantities can be added or subtracted. So this is all about. Please check out. So these are the 4 applications of dimensional analysis, and this is very important for exam point of view as well as for your entrance. So please go through this topic and put your doubt and make your habit to ask question during the class. Okay, so thank you.